Something strange is happening on Mars, something so unexpected that it has begun to reshape everything scientists believed about the red planet. For decades, we looked at Mars as a dead world, a frozen desert with nothing left but the ruins of its ancient past. But new signals, fresh seismic data, and one groundbreaking discovery beneath the surface have forced NASA and planetary researchers to question what Mars truly is and what it might still be. The truth about this planet is shifting. It is no longer just a relic, it may be alive in ways we never dared imagine. And if that's true, then the real question becomes, who will be the first to uncover what Mars has been hiding for billions of years? Not long ago, Mars looked very different. It wasn't always the dry, rust-colored wasteland seen in today's photographs. In its early years, Mars was warmer, wetter, and surprisingly Earth-like. Vast networks of rivers carved through canyons, lakes pooled in low valleys. Entire regions may have been covered by shallow oceans, and where there is water on Earth, life always follows. Microbes, bacteria, strange organisms. Every kind of biology we know depends on liquid water. It is the medium that carries nutrients, the solvent that moves oxygen, the lifeblood that allows cells to function. So when scientists confirmed that ancient Mars held water across its surface, the possibility of Martian life was no longer a fantasy. It was a scientific expectation. But something catastrophic happened roughly 3 billion years ago. Mars began losing its atmosphere. Without pressure, water cannot remain liquid. It evaporates, boils, or sublimates directly into vapor. As the atmosphere thinned, Mars's rivers didn't simply dry up. They escaped into space. What little water remained froze solid at the poles. For decades, this was the accepted explanation. Mars had water, Mars lost water, end of story. A neat scientific narrative tied with a bow, but that story has cracked open. The shift began with a humble robotic lander named InSight. While other missions explored craters, cliffs, and ancient deltas, InSight had one purpose: listen to the heartbeat of Mars. It touched down in Elysium Planitia in 2018, deploying a delicate seismometer beneath a protective white dome. No wheels, no lasers, no cameras searching the horizon. Instead, it listened for marsquakes, vibrations from deep inside the planet that could reveal its internal structure. For years, the instrument picked up faint tremors. The true breakthrough came on May 4th, 2022, when InSight detected the largest marsquake ever recorded, a magnitude 5 event powerful enough to send seismic waves circling the entire planet for nearly 6 hours. Immediately, planetary scientists launched into an urgent investigation. Had a massive meteor struck the surface? Such an impact would create a crater hundreds of meters wide. NASA's orbiters scanned every likely location. Nothing. No crater, no debris field, no sign of an impact at all. That left only one explanation. The quake came from within Mars itself, and that quake became the key to unlocking the planet's greatest secret. Seismic waves behave differently depending on what they pass through. Solid rock slows them slightly. Softer materials change their direction, and fluids, especially water, dramatically alter their speed. Deep underground, beneath 10 to 20 kilometers of Martian crust, the waves from the quake suddenly slowed down in a way that matched one specific signature: a massive reservoir of liquid. Mars, according to the seismic data, has an underground ocean. Not ice, not frozen soil, liquid water. A hidden reservoir so vast that if brought to the surface, it could cover the entire planet in a global ocean 1 kilometer deep. A shocking amount of water in a world assumed to be bone dry. This discovery contradicts everything scientists believed about Mars's climate, geology, and its potential for habitability. The question is not just whether the water exists, the seismic data strongly suggests it does, but how it got there. One theory proposes that Mars never truly lost all of its water. As the atmosphere collapsed, liquid water on the surface may have seeped into underground cracks and porous rock, retreating into protected reservoirs where pressure and temperature kept it from boiling away. Another theory mirrors Earth's own deep geology. Inside our planet, minerals like ringwoodite can trap enormous amounts of water within their crystalline structure. Earth's mantle alone may hold 3 times more water than all surface oceans combined. If similar processes occurred on Mars, the planet could have produced and stored water underground long after the surface dried. But there is a more tantalizing possibility: life. On Earth, we've discovered microbes living kilometers below the surface, surviving on chemical reactions instead of sunlight. We've drilled into ancient water pockets sealed off for millions of years and found organisms still alive. Even in extreme heat near 180 degrees Celsius, Earth's deep biosphere thrives. The Martian reservoir lies far closer to the surface than Earth's. Instead of 700 kilometers down, it could be reached at depths between 10 and 20 kilometers. Still unimaginably difficult to access, but not impossible in the long future of planetary exploration. If water moved downward as Mars dried out, it could have carried organic molecules with it. Life, seeking refuge, might have followed the descending water to its new home. And if even a fraction survived, Mars may not be just an ancient world where life once existed, but a living world where life continues today, in darkness and silence. The engineering challenges are overwhelming. Drilling even a few kilometers on Earth requires enormous equipment, energy, and stability. On Mars, where temperatures plunge, dust storms rage, and resources are limited, the challenge grows exponentially. Even companies on Earth known for tunneling, like Elon Musk's Boring Company, would find such a mission nearly impossible with today's technology. But the discovery remains: a massive underground reservoir of liquid water on a planet we believed had lost all its water billions of years ago. A world we called dead may be holding on to the last traces of its ancient heartbeat. This changes the understanding of Mars from a static graveyard to a planet still shaped by internal processes, still moving, still hiding, still evolving in ways we barely understand. It means Mars may not be simply a destination for future exploration, but a world already carrying the echoes of life. Science thrives on surprises, and Mars has just revealed its biggest one in decades. A quake that traveled around the world has exposed a truth buried under rock, pressure, and time. And the next steps, deeper sensors, future landers, advanced drills, could finally reveal what lies inside this hidden ocean. If liquid water still lives beneath Mars, then the story of the red planet is not finished. In fact, it may be just beginning. Life could have survived underground. It could be surviving right now. And if that's true, then finding it would not just redefine Mars, it would redefine us. If you enjoy exploring mysteries like this, consider subscribing. It helps Astreon grow and brings more cosmic stories to life.